And so then we see the intersection point here is actually at -10. Okay, so there's the graphical solution. Well, part of it anyways, where we're graphing the lines. Now, we're trying to see where is, or for what x values, is this expression, which expands out to be 4x minus 2, where is that less than 5x plus 8? Well, 5x plus 8 is this steeper line here, and 4x minus 2 is this other line here. So we want to know where, for which values of x, is this expression less than or underneath the line 5x plus 8. So if we take a look over here, 4x plus minus 2 on this side is actually above this line 5x plus 8. So that's where 4x minus 2 is greater than 5x plus 8. So we look past the intersection point at x equals -10, and we see that 4x minus 2 is now underneath or less than the line of 5x minus 8. So for all these x values greater than 10, the graph of 4x minus 2 is less than, in other words, underneath 5x plus 8. Okay? Now if you check on Desmos and you can graph both of those, you can actually put this whole inequality into the formula, or into the equation box, and you'll actually get the shaded area where all the x values are less than, or where the x values where this expression is less than this other expression here. Okay, so I'm going to just expand this through here. So I'm going to get -2 plus 4x less than 5x plus 8. Do this algebraically now. And then I will subtract 5x from both sides and add 2 to both sides. And then we get -x less than 10. And then anytime you divide by a negative, we're going to change this sign. It switches around, so then we multiply both sides by -1, we get x is greater than -10. So x is an element of all real numbers such that x is greater than -10. That's the set notation form of the solution, or we can say x is an element of -10 to infinity, both with round brackets because neither of these are included in the solution set. Okay, so if you haven't gone on Desmos yet to graph those, why don't you graph this and graph this one and see how they compare to the solutions that you found algebraically. Check back in a second and we'll come back to the next two examples in a few seconds. Okay, so we'll move on to this next example. So we want to solve this inequality algebraically, and then we want to check the solution by using a test point. Okay, so all we're going to do basically it's the same process as solving for a variable in an equation, but we're just using inequalities. Okay, so I'll just go through this slowly with you, and then I'll ask you to do the second example on your own. So first of all, I'm just going to expand through those brackets to get 2x plus 6 less than 4 minus x, because I expanded in this negative, into this bracket, so that becomes -x, this becomes +4, and then just turn them around to give this. And then I added x to both sides to get 3x. I subtracted 6 from both sides to get -2. And then I divide both sides by 3 to isolate the x. So we got x is less than -2/3. So for all x values less than -2/3, according to my algebraic solution, this expression 2 quantity x plus 3 is less than negative quantity x minus 4. So now that we have this algebraic solution, I could write it in interval notation just to show what this would look like if it were true. So because it's less than negative 2/3, x is an element of all x values less than negative 2/3, or between negative infinity and negative 2/3, and it has both round brackets on either end because neither negative infinity nor negative 2/3 are included in that in this range. So we use a test value, and so we're going to test x equals negative 1. And what we're going to do, instead of substituting in negative 1 into this inequality as it is and then work out both sides while maintaining that negative or that inequality sign in the middle, what we're actually going to do is we're going to separate the left side and right side and do them individually, just to make sure that we are actually testing to see if left side equals right side or left side is less than right side. Okay, so the appropriate way to do this is to separate left side and right side. So left side equals 2 quantity x plus 3, the right side equals negative x minus 4. And then we're going to substitute in this test point of negative 1. And the reason why I'm using negative 1, sorry, just to get back to this for a second, is because negative 1 is less than negative 2/3, so it falls in this range. We could have used negative 2, negative 5, negative 10, negative 50, negative 76. It doesn't really matter. As long as it's less than negative 2/3, it's in that range of values. And you may as well make your life easier by using as simple numbers as possible to use as a test point. Okay, so that's why I'm using x equals negative 1. So I'll substitute that in to x here and x over here, and then I'll just work out the brackets, and we see that the left side equals 4, the right side equals 5. Therefore, the left side is less than the right side because 4 is less than 5. Therefore, x equals negative 1 does satisfy the inequality, and that means that the range of values, of x values, from negative infinity to negative 2/3 is the solution for this inequality here. Okay, so now if we do the same thing for the second example, I'm going to ask you, I know it's a little bit more challenging, but I'd like you to work through the same process, do the reverse order of operations to isolate for x, and come up with some statement of which x values would satisfy this inequality. Once you finish that, choose a nice round, easy to use value of x that falls within that range, and test your solution. Okay, so pause the video now and check to see what your solution would be.